This is the last video. Okay, you guys got this. This is the end of intermediate algebra. You're going to do great. Okay. So in this one, section 6.6, we're just going to kind of talk about quadratics in general, talk about their graphs. The big thing is I'm going to teach you 3 ways to find the vertex. Okay. And yeah, and then we'll just kind of wrap it up. I do have some word problems to talk to you about because I know you saw some word problems in 6.4 and 6.6. You'll have some word problems. So I do want to discuss those with you. But let's go ahead and let's start talking about finding the vertex first because that's the important piece. And then we'll hit up all that other information. So the first way of finding the vertex is if you are given vertex form. And as you've seen vertex form before, back in 6.5, in vertex form, the reason why we call this vertex form is because we are actually giving you the vertex. The H and the K are the vertex. Now, when you plug into the vertex, again, because the formula has a subtraction here, when you plug into the vertex, I need you to think the opposite. I don't know why I put app. I need you to think the opposite of the value. And then keep the K. Opposite, keep. Okay? So if you had a minus 3 here for H, that would be a positive 3 in here. If you had a minus 5 here for K, that would be a minus 5 down here. So keep the sign for the K, but think opposite sign for the H. Okay? Go ahead, pause the video, give these two a shot. All right, so up here, the vertex, here's the H, here's the K. Opposite of a negative 8 is a positive 8. And the K we keep, so it's a positive 3. And there's the vertex. It is that easy, I promise you. All right, so let's take a look at the next guy. Here's the H, here's the K. So the opposite of a positive 5 is a negative 5. And since this is a negative 2, it'll stay negative 2. And there's the vertex. So that's method number 1. If you have vertex form, and it has to look like this, a parenthesis x minus h parenthesis squared plus k. If it doesn't look like that, then we have to go to another method. But as long as you have vertex form, the reason why we call it vertex form is because it gives you the vertex. With the opposite, keep. Method number 2, we do this algebraically, okay? So this is if you have standard form, which is what we've been working with this whole time. When we were in 6.1, 6.2, and in 6.4, all those quadratics that you were given were all in standard form. ax squared plus bx plus c. Okay, so here's how we deal with it in standard form. The first thing you're going to do is find what I call the axis of symmetry. It is this formula right here. Okay, so you're going to run the axis of symmetry. This is the opposite of b over 2a. Kind of looks like basically the quadratic formula without the discriminant. And that's exactly where this piece is kind of coming from. This is the opposite of b over 2a. Okay, then once you know what x is, because that will be the x part of the vertex, you'll know this guy. How do you find the y part? Well, you plug in x and solve for y. Okay, and that's how you find the vertex in standard form. This is what it looks like in its algebraic glory. So again, this is finding your x, which is the axis of symmetry, and this means to plug it in. Okay, this is finding x. This means plug in x and tell me what y is. That's all this means. But this is what it looks like really algebraically. Okay, so let's do this. I believe I've got 2 problems of this. Yep, and then we'll use the calculator. So let's walk through one together. So the first thing we're going to do is find x. That's the opposite of b over 2 times a. Well, my b up here is a negative 8. What's the opposite of a negative 8? A positive 8. And I've got 2 times, what's my a? It's right here. That's the A. So that's 2 times 1. So 8 divided by 2 times 1 is 2. 8 divided by 2 is 4. So the axis of symmetry, which I abbreviate AOS, is this x equals 4. What that means is, what the axis of symmetry really is, I know I didn't touch upon this a second ago, is that my graph, there is a line that goes through the vertex. Okay, that's my vertex right there. This line right there is the AOS. The AOS is what cuts my quadratic in half, where if I took half and I gave you the other half, we'd both have the same amount of graph. So the axis of symmetry is this line. And it is a vertical line, so it is x equals a number. That's very important for you to understand, that the axis of symmetry is this equation. But more importantly, this axis of symmetry, like you saw a second ago, it tells us that the vertex, the x value is 4. All we need to do now is find the y value. How do I find the y value? Well, I'm going to take this 4 and plug it into all my x's up there. So you've got 4 squared, because that was x, minus 8 times 4. Make sure I write this down right. So 4 squared minus 8 times 4 plus 4. And just go to your calculator, let it do its job. 4 squared minus 8 times 4, and then it was plus 4 again. Plus 4. There's your y value. Okay? Let the calculator do all that work for you. Just plug it in the way that it is. So we know that this was a negative 12. So now we know the vertex is 4 comma negative 12. And there you go. See, not that bad. Okay? All right. So go ahead, pause the video, give this one a shot. Okay. So hopefully the first thing you did was find that axis of symmetry. So x equals the opposite of b all over 2a. Here is b. Here is the a. So opposite of a positive 12 is a negative 12. 2 times a is a negative 2. So we got the opposite of 12. All over 2 times the negative 2 is negative 4. And now we know the vertex is 3. So the AOS, just repeating what we talked about a second ago, the line that cuts my quadratic in half is x equals 3. And in the vertex, because we now know the AOS, we know that the x value is 3. We need to find the y value. Again, how do we find the y value? We just plug in the 3 for x. So negative 2 times 3 squared plus 12 times 3 minus 5. Okay? Also, just so you know, sometimes this doesn't work out quite as nice and it's a fraction. Fractions would do the same thing. Just let your calculator handle the fractions. Okay? So if this was a half, I'd plug in negative 2, a half squared, using my calculator. Let the calculator handle it all. So going in here, negative 2, 3 squared plus 12 times 3 minus 5. And there's our value, 13. And now you know the vertex. So now you know how to find the vertex 2 different ways. If you have vertex form, it's easy. You got h and k. If you have standard form, you just do the axis of symmetry, and then you plug in the x and find the y. Last but not least, let's talk about how your calculator can help you. So in the notes, I've given you how to punch stuff into the calculator. So just use those. But the big thing that you need to know is that when we're using the calculator and dealing with this, you have to know whether you have a minimum or a maximum. That's going to be super important. So you have minimums. Again, this is going back to that 6.5 that we were talking about. Minimums are when your A is positive. So remember that if you're looking at your equation, if you have a positive A, it's going to be a minimum. So that means we need to make sure that when we find your vertex, we're looking for a minimum. Remember that you will have a maximum if it was a negative A in your equation. Okay? So, minimum and maximum. You need to know which one you have. All right, so I've got two problems right here. I'm going to work the first one with you, and then we'll talk about the second one. Okay? So the first one, we're going to go into our y equals, and we're going to put that equation in. Negative x squared plus 4x plus 3. So this is another way to deal with standard form, plus 4x plus 3. Let me double check that. Yep. And so if we hit graph, oh, I didn't fix my graph. I need to go in here and go down to zoom standard because notice my graph wasn't there. So whenever your graph is messing up, go down to zoom standard. There's my graph. So you notice it's an arch, so that means we have a maximum, okay, which is very important for us because in order to find this vertex here, you're going to hit second trace. Notice there are two important words on the screen. Maximum and minimum right here. Maximum and minimum. Very, very important words. Okay? So which one did we have? We had a maximum. So we're going to scroll down to maximum. And here's what you're going to do. So it's going to ask you 3 questions. The first question says left bound. That means if this is the vertex, it wants you to be on the left side of it. Okay? So left bound means be on the left side. So I'm going to scroll over a little bit. Get a little bit closer to it. So left bound, again, means be on the left side. Here's my vertex. I'm definitely on the left side of it, so hit enter. Notice a little arrow pops up. That's good. That means you're telling your calculator, do not go beyond this left arrow. Now it says right bound. So I want you to be to the right of the vertex. So here's my vertex. I need to be over here to the right. So I'm going to scroll past my vertex, definitely on the right side now. Hit enter. Notice there's a right arrow. Okay, so now your calculator knows, oh, the vertex is between here somewhere. Okay, so we're going to scroll. And the third question says guess. So I'm going to put my cursor scrolling back to the left where I think the vertex is. And I think it's right about there. And all you're going to do is hit enter. And there's your vertex. Now, notice there's all these decimals here. If you have 0.0000000 and then it gives you some numbers, that means this thing is really at the number 2. Okay, your calculator is doing a lot of extrapolation and interpolation in there. So it's doing a lot of work behind the scenes. So these 0.0000013 just need to be knocked off. The vertex is 2, 7. The same thing if you have 0.99999999999 blah 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 blah. That means rounded up. So if this was 2.999999999, I would have said this is 3. Or if this is 1.9999999, I would call this 2. Okay? So if you got a lot of 0.9s, round it up to the next number. You got a lot of 0.0s, just knock it off. Okay? So now you know the vertex. 2, 7. So vertex 2, 7. And there you go. So go ahead, pause the video, use your calculator, find the next guy. Okay, so if we come back in here, clear this out, let's put in our next guy, 2x squared plus 8x plus 3. So 2x squared plus 8x plus 3. Hit our graph. Notice it's a minimum this time. So hopefully you hit second trace. You go down to minimum. Okay. And again, it asks you those three questions. B to the left, hit enter. B to the right, hit enter. Then guess, enter. And it's going to tell you the answer. So I need to be to the left, so I need to scroll past my vertex. Definitely on the left side now. So I need to be to the right, scroll past the vertex. Definitely to the, oops. Said error bound, that was my fault. Graph. Second trace. We're finding a minimum. So I'm going to be to the left. Enter. I need to be to the right. Enter. And then I need to take a guess. Close enough. Hey, there's that 0.99999 that I was talking about. So that means round this up to -2. And your y value is -5. Okay? So the vertex, -2, -5. And there you go. There are three ways that you can find the vertex. You can use, if it's given to you in vertex form, it's right there for you. If it's in standard form, you can use the calculator or you can do some math doing the axis of symmetry and plugging that information in. Okay? I don't think there's anything after that. Nope. So what I want to talk about is just some of the problems that you're going to run into in your homework, just to clear up some things for you. So in your homework, you're going to run into some word problems. So this is in 6.4. Okay. So in 6.4, it's asking you to find the perimeter of a rectangle that is 62 meters and its area is 228 meters. Okay, so since this is in 6.4, you'll be using the quadratic formula. Remember, perimeter means to add up all the sides, and area means that it is the length times width because it's a rectangle. Use the quadratic formula for this. Okay, and notice it says round to the nearest hundredth, so watch your rounding. And question 7, eventually it will come up. Okay, it's not liking my pen. So question 7. I wonder if this is because I'm recording. Well, question 7 was about a distance problem. Let's see if I can refresh this. Question 7. There we go. So in this one, they give you the equation here. All the stuff up here is just fluff and stuff. So they give you the equation here. And then down here it says the object is 179 feet off the ground. Okay, they want to know how long does it take to get that, so you're solving for t. This 179 feet, it goes in for h. Okay, so since this is equal to 179, you're going to run the quadratic formula. Remember, quadratic formula must be equal to 0, and watch your rounding. Okay, so this 179, it goes in for h. Just wanted to give you a heads up on that. Some other things that you're going to see in 6.6. So when you get to the second question, notice it's going to ask about some x-intercepts and y-intercepts. I want to review how to find x-intercepts and y-intercepts using your calculator because you can. Okay. So in your calculator, our equation was, sorry, I keep jumping all over the place, 9x squared minus 16. So let's go in here. 9x, whoops. Let's delete that out there. There we go. 9x squared minus 16. So there's our graph. That's okay. That we can't see the y-intercept. We'll just talk about that here in a second. But notice we have these little points that are right here, these x-intercepts. Okay, so let's figure out what these are. And again, I believe we talked about this, but I just want to make sure. If you hit second trace, this one right here that says 0, That's so that you can find x-intercepts. The 0 is to find x-intercepts. So you scroll down to it, and this is going to be a lot like the minimum and maximum case. So it's going to ask you those same 3 questions: B to the left, B to the right, then guess. So you're going to pick one of these to do first. Okay, so let's do the negative side first. So I need to be to the left of it. So I'm going to scroll back. Eventually you'll see your cursor. See how it's jumping? So I'm definitely to the left of this now. Hit enter. There's my arrow. B to the right. So scroll past it. Hit enter. There's my other arrow. So again, my calculator knows somewhere between these 2 arrows is the answer. So now we scroll up. Try to be as close as you can to it. That's as close as possible. Hit enter. And there is your x-intercept on the negative side. Negative 1 1/3. Okay? Or in other words, negative 4/3. Okay? Let your calculator turn this back into the fraction for you. Negative, we can go out. Oops. Hit quit. We can go out here, put negative 1.3, and put in lots and lots of 3s. See, that's a lot of 3s. And then go up and do your alpha y equals. Go to number 4, and it will turn that into the fraction for you because it will want the fraction answer. See, negative 4/3. So again, up in here, how do I find that x-intercept? Second, trace, go down to number 2. Zeros are the same things as x-intercepts. Okay? So again, it wants you to be to the left. Let's go find the positive one. So we need to be to the left. Eventually, hey, there's my cursor. That's to the left. I'm going to be to the right, so I scroll past it. I'm to the right, and now I want to try and be on it. So that's as close as possible to it. And there it is. So it's, again, this one is a positive 4/3. Okay? So there you can use your calculator to help you find x-intercepts. Another way that you can find x-intercepts, all these methods that we have been using, the square root method, factoring, quadratic formula, are all ways to find x-intercepts. So if you wanted to, you could set this equal to 0 and factor this because it's factorable. You could use the square root method on this because you have an x squared. Or you could do the quadratic formula on this and you will get those same answers. Okay? The y-intercept, if you want to find the y-intercept, one way to do that, plug in 0 for x, and that will give you and figure out what happens when you plug in 0 for x, and that's the y-intercept. Another way to do it, on here, if you hit second trace, you can do value, because value will find the y-intercept. Because once you click on it, tell us what you want x to be. We want x to be 0. And there it is. There's your y-intercept, negative 16. So again, if you want to find the y-intercept using the calculator, second trace, click on value and tell it that x is 0. And there's your y-intercept, negative 16. Okay, so some of these questions are going to ask about that information. What are the x-intercepts? What are the y-intercepts? See, I'll show you again. Well, not that guy. Oops. We need to go, this should be in the 6.6 homework. That's weird. Let's refresh this. There we go, 6.6. That was weird. So there's that question that there's, finding x-intercepts, y-intercepts. We just talked about that. Okay. Find the vertex. Here we go. Finding the value of f of negative 5. So again, they just want you to plug in, find the vertex, find the y-intercept. We already know how to do that. Okay. And then you're going to get to some word problems in 6.6. So in this 6.6, it says this: assume the rocket will splash down into the ocean. At what time does the splashdown occur? All right, so h up here is the height of the rocket. Well, how high is the rocket if you splash down into the ocean? Hopefully you said that this is 0. So what it wants in here is it wants you to either run the quadratic formula or You can try and use your calculator to help you out, but these are really, really large numbers. My advice to you right here is run the quadratic formula for this guy to figure out this answer. And it's going to be a decimal answer, okay? Because these are just nasty numbers. So in here, in this first question, the rocket splashes down after what? Run the quadratic formula because you're going to be set equal to 0. Because when it splashes down, the height is 0. Okay, now this next question, it says, how high above the sea level does the rocket get at its peak? When you're looking for a peak, that's a maximum. Okay, a peak is a maximum. So anytime you see those words maximum, or some of these might ask about a minimum, it wants you to find the vertex, specifically the y value. So right here, when it says what is its peak, that's a maximum. So take this equation up here and find the vertex and find the y value. Okay? Question 6, just to kind of talk about it. Hey, look, maximum. Oh my gosh, we just talked about that. Maximum means find the vertex. How many seconds does it take until the ball hits the ground? How high is the ball when it's at the ground? That's 0. So run the quadratic formula for this. Okay? This is just like the previous question. They just flipped the order. The first question is all about the maximum. The second question is all about, which is the vertex is the maximum. Okay? And then the second question is all about running that quadratic formula to help you. Okay? When in doubt on weird equations with large numbers, run the quadratic formula when you're finding something that hits the ground or splashes down. And that is everything you need to know about 6.6. Good luck. You did it. You guys got this.